Okay, hello again. So let me show you something which will let's now introduce some 3 points which will be somehow randomly spread on this surface. Okay, and these 3 points will become so-called attractor points, and these 3 points will somehow make some effect on the closest circles. Okay, so basically as the circle gets closer to a point, it changes the radius. Okay, so and we'll have not only 1 point but 3 points. So let me go back a little bit to the beginning of our script somewhere here, and I'm gonna create a point at parameter. Okay, and let me go here, and then I'm gonna create the first point at whatever 0.30. I'm gonna later on we can change this, or even let's do something like let's use sliders, right? So slider, number slider, and I'm gonna use the slider between 0 and 1. Step, let's make it a little bit higher resolution, so it will be like between 0 and 1 with a step 0, 0, 1. Okay, so what we have now is something like, sorry, Control C, Control V. Okay, so the first point is here. Okay, and actually what you need to know is that, okay, if I move this point along you, right, so the point moves here, right, that's here. Okay, but if I want to go on this side, so let's say I'm gonna move to 1, I need to go beyond 1. Okay, so actually what I would need to do is, because actually this surface ends up here, okay, at this here, but since it's mirrored, okay, if I increase this to 2, not 3, not 4, but just to 2, okay, with this I'm able to go beyond, and it still will follow, of course, the topology of the surface. Okay, but this happens only exclusively if this part of surface is mirrored on the other side. If I would go like, I could also go beyond 1 here, but then of course it would follow the last parameters of the surface, of the last parameters which represent the curvature of the surface on the edge. So probably it will go like ooh, something like that on this side. But here of course we are dealing with the surface which is mirrored, so we can do that. Okay, so we have I have here 1 point. Let's put it maybe somewhere here. Okay, okay, and before we start, actually I would like to show you, of course, before we do something a little bit more complicated, let's find out what happens if we create only 1 point attractor, and later on we'll add 2 more point attractors. Okay, so what I have to first do is I have to measure what is the distance between basically my attractor points, which is right up here. Okay, maybe I will create a circle or sphere. Okay, so it's a little bit better visible, like 5. Okay, so this is my sphere, which is based on points. So if I move, yeah, so it moves here. Okay, so I'm gonna measure what is the distance between my circles, or to be better say my points, and my circle. Now I have to do a little bit some very minor modification, because what happens here is that I have this structure with this list with structure, so it has sublist, 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 sublist. Later on, maybe it will be too complicated to explain why, but what I need to do is to flatten this list, because what I need to have actually is one single list of points in order later on to this will basically help me to get a nice effect of this let's say of how this attractor affects the circle around. Okay, so but once I flatten this list, so I get rid of, I didn't delete any point, I didn't delete any branch, any sublist of this tree, any branch of this tree or any sublist of this list. I just flatten it, so it doesn't have this structure anymore. Look, that the point, this point is always still the same first here, and this point is not, it's just not the first of the sublist, but it's just on 4, right? Index 4. Okay, so what I need to do is to substitute my points, these which have been, let's say, structured with a completely flattened list. Okay, and now, because why I did that? Because now if I connect geometry distance 2 with my point, with this sphere, actually with the center of the sphere, what I need is what I get is a list of distances. Okay, with this list of distances, what I can do is actually I should do look, if this distance will depend on the radius, then of course we'll have like this circles will become too big, of course, because it's just distance, right? I could of course linearly divide them by 20, for example, so I get smaller numbers. Okay, and these smaller numbers will look like this, but again, it's still very, very linear. Okay, even if I decrease it like till let's say by 50, right? So it's still, these are super small, and I don't see really that this is changing like gradually, or it's changing gradually, but it's just at the end this effect is not nice. So what I'm gonna do, I'm gonna use the a node called remap range, which actually allows me to proportionally flatten the numbers, or proportionally decrease the numbers. Okay, so I don't have, so if you type in here, new minimum of my list will be 1 and new maximum of my list will be 6. Okay, so I get the same list, or the proportions between these numbers are the same, but the values are significantly decreased. Okay, now I'm, as you could see, I'm ranging between 1.8 and 5 and 6, basically, right? So, and now if I substitute my instead of having constant radius 3, but I'm gonna have a constant, but not constant, but this kind of number, you see that of course it is basically like this change is more, let's say, it just looks a little bit better, right? So the circles do not overlap and so on. However, and yeah, let's even maybe increase the number to 7, so the furthest circles are becoming a little bit just bigger, right? However, what I need to do now is I need to basically, so what I need to do is avoid a situation in which this change is linear. Okay, because when it's linear, actually the difference between, for example, this circle is really not really perceivable, and this from this is also very similar, so and this from here, so I don't see really that much difference between. Of course I can increase the number of course I can increase the number of columns and even the space between them, so up to decrease the space, so to 20, let's make 20, or even maybe like something like that. And then I can increase the number of columns maybe to 44. Okay, but still it doesn't look that good, that great, right? So the next thing I can do here is actually I can convert this linear change to a parabolic change. Okay, you remember from the school what's the difference between the graph of a linear and the parabolic function. Okay, so if I turn it to from that my numbers will be like let's say first I'm gonna type in 0.5 times x square. Okay, but here the problem is that here in design script this doesn't work. Okay, what you need to do is type in math, then you're calling mathematical functions, power, right? Then your number which you want to put into the power, okay, and second power, okay, to square. So basically this is the equation of a let's say of a parabola, right? So like parabola, but because of this number at the beginning, my parabola becomes a little bit more flatter. Okay, so I'm gonna use this, and I'm gonna substitute with my radius. You see that, of course, this change become a little bit more, looks a little bit better. Then, of course, I can also say I want, for example, not 0.5, but make it steeper, my parabola, which means like if I do 1.2, then this change will become something like that. But then the problem starts here, right? So let me do one more last modification to the script, which allow us to basically to avoid this situation where the circles are overlapping. So I'm gonna check if these are these numbers, let's say, because I can assume that if this number exceeds, let's say, probably 8, they start to overlap. Okay, if a radius exceeds something like 6 or 7, they start to overlap. So I will check if this is bigger than 6 or equals 6. Then I'll get the number, the list of answers: false, 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 and then at the end, of course, true, 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 because these circles which are far away become they start to overlap, because they're probably bigger than, the radius is bigger than 6. We're gonna find it in a moment if it's 6 or 7, but it doesn't matter. Now, if I will apply a node called replace by condition, okay, now this is a little bit weird how it works, but I need to do the following. So this is my list, okay, condition, okay, so actually when I put it here, this node understands immediately that condition is defined by this operator, okay, and then okay, if something is equal or bigger of or 6, then please replace it with 6 radius. It's probably even bigger. I can see probably 7, right? Or even 8. Oh, let's keep it 7. But as you could see here, I have already I have better control over like how this. And by the way, if I use again slider, my number slider will vary from 0 to, not from 0 because I cannot have 0 here, from 0.1 to, let's say, 2 will be already a lot. If I substitute this, and by the way, yeah, let's maybe increase the resolution here, so the step will be a little bit smaller. And here, let's convert this into A, like in. And look, if I increase this, this will become steeper and steeper, right? If I decrease the number, so if I make the parabola flatter and flatter, this will become, I will see the effect again on the screen. Okay. Here, of course, yeah, I have the circle which is laying outside. I could also, again, there are some different methods to remove the circles which are already not on the which are basically outside of surface, but this maybe it's not for this moment. Let's maybe increase a little slightly the distance. Oh, yeah, this we might face this problem quite often, but nevertheless. Maybe let's keep this 19. Yeah, probably 20 is the best, around 20. But anyways, what we can do now is we can bake it to Alias. Okay. Immediately I have my result here, right? Of course, I don't see at the moment. I don't see the tractor because of the pointer tractor because I didn't place it here, of course, right? But the effect is here, and of course I can also start using and start moving my if I move my circle again, it will also be affected on the graphically, right? Okay, let's stop this video now and let's come back and let's hear each other again in another video.